Hello guys, welcome once more to physics class online, and my name is Mr. Damilola, and in this video we shall be looking at JAMB Physics 2020. Okay, and we shall be solving question number 21 to number 25. And don't forget to like our video so that you can get more content from us from time to time, and also tell your friends about us so that they also can partake from this. We have much to share with you, we have much to explain, we have much to show you that will help you in your journey to mastering and understanding physics. So let's check number 21. What did it say? It said a convex mirror is used as a driving mirror. Because why do we use convex mirror for driving mirror? That's why do cars have convex mirror and not concave mirror? A, its image is erect. B, it has a large field of view. C, it has a long focal length. Now identify the correct statement. A 1 and 2 and 1 and 3. B 1 and 2. C 2 and 3, and D 1, 2 and 3. Now, do you have any idea which one might be right for images of convex mirror? Any idea? So let's take a look at it now. Okay, so this is convex and concave mirror. You know, convex mirror have smaller image, that's diminished image, while concave have magnified image. So the properties of images conformed by a convex mirror is that number one, they are virtual. That means they are photographic. Then that means they are not real. Okay, so 2, they are diminished, and 3, they are upright. So if you look at that's why when you are driving and you look at the side mirror of your car, you will see that something is written on the mirror that the images you are seeing are bigger than what you are seeing. That means they are diminished. That means you are seeing the car behind, but the way you are seeing it is that it is smaller than the way it is. It is farther. You will see that it will appear farther than the way it really is. So that is. It is because it is diminished. It looks smaller, but actually it's not smaller. It is bigger than the way it appears on the mirror. So convex mirror makes image diminished, virtual, and upright. So, and also just to add to it, use of convex mirror, we use them for car driving mirror. Yes, we know that from the question. Then we also use them for supermarket security mirror. Have you ever been to a supermarket that you saw a large mirror? That is a convex mirror. It makes a big mirror making people look smaller. Okay, that's the convex mirror. It makes images to appear smaller than they really are in real life. So that's it. So what option is correct? Option 1 says the image are standing upright or erect. Erect means upright, and that is true. Option 2 says it has a large field of view. It views things in a large way and makes them smaller. That is also true. But option B said it has a long focal length, and focal length affects the magnitude, and that is not true because the image gets diminished. So the focal length is not long, and that makes option B the wrong answer. The only true answer for a convex mirror are option 1 and 2. I hope you get it. So let's check the next question now. It says 2 mirrors of the same length are arranged as shown in diagram fig 4. A ray of light NO strikes the system at O emerged along PQ. The emergent ray has been deviated through what angle? Now, what angle has it been deviated? Now, this question is simply asking that find the angle of deviation of this ray. That's what the question is simply saying. Find the angle of deviation of this ray. Now, let me remind you of something. The angle of deviation is double the angle of glance. Now, that means if I have a reflection of this order, now the angle coming this way is called the refractive. The incident angle coming from the incident ray. That's the ray of light coming in. Then it strikes the normal. It strikes the normal and then reflect or refract or bounce back. Okay, so this is actually a reflection. It came to the normal and then reflected, right? Now that angle, the R, represents the angle of reflection. okay, or the reflected angle. Then the one below the two of them is the angle of glance. Now, two angle of glance makes the angle of deviation that this answer and that this question is looking for. So two angle of glance makes one angle of deviation. So this question says find the angle of deviation. Now look at the question there. So I have that drawing. Don't mind me, my drawing is somehow small. So we have 40 degrees below. Now you should also know that the angle at the opposite side below, because you know from my drawing I have G equals G, GG, right? So if the lower part is 40, the second part, that's the red place, the second part where I put a red color is also 40 in my drawing. So we have 40, 40, right? Now if that's 40, now that forms 40 in the triangle that it forms in the drawing. In the triangle in the drawing we have 40, therefore at the red point is 40. So that means the lower part of a triangle is 40. Now, and for a right angle triangle, we know that the inner part is 90 because it is perpendicular. So we have 90 and 40 to find the last part, which is G2, the second angle of glance. Okay, so we have 90 and we have 40. Don't forget that the first angle of glance is 40. Okay, so the second angle of glance is G2. So we have 90, 40, and to find G2, you know the sum of angle in a triangle is 180. So we have 90, 40 plus G2 equals 180. 90 and 40 is 130. Okay, plus G2 equals 180. So G2 is 180 minus 130, giving me G2 as 50. So the second angle of glance is 50, and the first angle of glance is 40. So the angle of deviation is therefore for each angle of glance, double of the angle of glance is the angle of deviation. So I have that. So we have 2 of the first angle of glance plus 2 times the second angle of glance, giving me 2 times 40 plus 2 times 50, giving me 180 as the total angle of deviation of that shape. The reason is because the shape has 2 angle of glance. Okay, the first angle of glance is 40, double of it is 80. Then the second angle of glance for my working is 50. Double of it is 100. 100 plus 80 gives me 180 as the total angle of deviation of deviation place of that shape. So that makes option D the correct answer. Don't forget the working is something you can do. Just follow the method and you have no problem. Okay? Okay, so good. Let's check number 23. Number 23. A magnetic needle is suspended first at the Earth's north magnetic pole and then to a point on the magnetic equator. The respective angles between the needle and the horizontal are what? Now there are quite some things I would like to teach you or explain to you that will help you to answer questions on magnetism in this question. And those things are very important because they always come out under theory sections of past questions. And those things are the angle of inclination and the angle of dip. You know, the angle of dip is the angle of inclination, and the second angle is the angle of declination. So we have angle of inclination and the angle of inclination, or the angle of inclination is the same as the angle of dip. It's very important to know. Then the second one is the angle of declination. Okay, so now for you to answer this question, it says that the Earth's north magnetic pole. You know, we have normal north, the north pole. Then we have the magnetic north. They are not the same. The actual north of the 4 cardinal points, you know, we have north, east, south, west. North, east, south, west. The actual north of the Earth is north, east, south, west, and this is my north. Good. But for a magnet that is suspended, the magnet's north is this way. Okay. So the magnetic north is different from the Earth, from the geographical north. Okay. So the first thing to know is that magnetic north and geographical north are aligned when the so-called angle of declination, the difference between the two north at a particular location is 0 degrees. So the angle between the angle of the magnetic north between the magnetic north and the geographical north is 0 degree. Okay, that is clear, right? Now I wanted to take note or understand what is called the angle of declination and the angle of dip or the angle of inclination. Those two are seriously important for you to know, for the sake of theory questions in past questions, because I noticed that the two of them are seriously emphasized in theory aspect of questions. So I will just make a speech on that now. Now, angle of declination is the angle in the horizontal plane between the magnetic north and geographical north. That means you can see in my drawing I have a magnetic north and a geographical north. That angle between them is called angle of declination. So if you were asked that to give what is the angle of declination of a magnetic substance, it is simply the angle between the magnetic north and the geographical north. Full stop. Okay, but the angle of dip or angle of inclination is the angle between the horizontal and the earth magnetic pole. The angle between the horizontal, that's the horizontal, and the earth magnetic pole. The angle between the horizontal and the earth magnetic pole, okay, is called the angle of dip or the dip angle or the angle of inclination. And those two understanding will really help you to understand a very key aspect of magnetism, okay, of the topic magnetism. So the answer to this question is the angle between the magnetic north and the geographical north is simply 0 degree, and that gives us the answer as A. The angle between them is 0 degree and 0 degree. Okay, so that's number 23. Now let's check out number 24. A hydrometer is an instrument for measuring the what? Now generally, if you hear hydrometer, the D sound should remind you of density, relative density. Hydrometer is used for measuring relative density of substance, but we have two relative density there. We have B says A says depth of water, that's a lie. C says relative density in the air, that's also relative humidity. That's not hydrometer. Humidity is for hygrometer. Now separate them. For humidity is hygro for humidity, but D for density and D for hydrometer. It is for relative density. Now let's talk about that now. Which of the two is correct, B or C? Relative density of a liquid by the method of flotation, relative density of a liquid by finding the apparent laws of weight. Okay, good. So let's check it out now. Now, this one says hygrometer and how it works. Now, I will use this to explain to you how the hygrometer works and which one is correct. Now, hygrometer measures a liquid's density or specific gravity. Now, actually, density is the same as specific gravity. I'm really saying the same thing. So I can say density or I can say specific gravity. I'm saying the same thing by the principle of flotation. Now, it was by the principle of flotation. Now, how do you measure the relative density of a liquid using an hygrometer? Just put the liquid in a container. Then put the hygrometer in that container. The hygrometer will stand straight in the water. Make sure that it stands straight. When it stands straight, I mean it will stand straight on its own. You will have to remove your arm. Just drop it gently. It will stand straight. The point it is standing straight is the point of the density of water. That means it is the point of the relative density of the water. Okay, and you know, of course, relative density means it is the number of times the liquid is lighter or heavier than natural water. So that means, what I'm saying is that relative density of that water that the hygrometer is showing is the amount of time that water is lighter or heavier than water, natural pure water. That's the meaning of relative density. Okay, so it was by the principle of flotation or Archimedes principle. You know, that principle says that what the amount of water being displaced is equivalent to the what? To the upthrust. Okay, it is equivalent to the upthrust in the liquid. Okay, so that's Archimedes principle. So that's the answer. So making option B the correct answer. Relative density of a liquid by the method of flotation, not by the method of apparent loss. It does not displace liquid. Okay, it does not work by displacement. It works by flotation method. Like my drawing, you can see the hydrometer was floating in the water. It didn't displace the water, it just floated. It was by the principle of flotation, not by the principle of loss of weight. Okay, so that answers number 24. So let's check number 25. This number 25 said, consider the three forces acting at O and in equilibrium as shown in this figure. Okay, which of the following equation is correct? The first one said that P1 cos theta 1 equals P1 cos theta 2. Okay, is that correct? That means P1 cos theta 1 is the same thing as, that means the one going up is the same as the one below. Seriously, is that true? Then 2 says P3 equals P1 cos theta 2 and 1 plus P2 cos theta 2. Okay, then the third one says P1 cos theta 1 equals P2 cos theta 2. Okay, that is that means that actually number 1 and number 3 are the same. They are actually, oh no, not the same, because the second one said P1 cos theta 2, then this one said P2 cos theta 2. Okay, so let's see which one is correct. Now the next slide will explain that. Now look at this. Now we have P3 going straight, we have P1 up, and we have P2 up. Now the first thing to do, if you have an angle, and you know, this is like a vector, but this topic is under equilibrium, you have to convert the one that has angle theta 1 and theta 2 into a straight line, going horizontally. So, and to change that P1 theta 1 into horizontal direction, you will need to find the horizontal component of that force, and that is P1 cos theta 1. Okay, then for the one below, you will need to find the horizontal component that will become P2 cos theta 2. Now, to find the force moving this way, that's opposite to P3, you will now need to do what? You will now need to add up P1 plus P2, and that will become P1 and P1 cos theta 1 plus P2 cos theta 2. And that means that since the two forces are now in equilibrium, that means the one going this way, that's P3, and the one going this way, that's the two of them, are in equilibrium, means that they are equal, because equilibrium came from the word equilibrium. That means P3 and the two of them, that's P1 cos theta 1 plus P2 cos theta 2, are equal. So that means that the two forces are equal. That means the answer to that question is P3 is equal to P1 cos theta 1 plus P2 cos theta 2. And that brings us to that answer to the question as option B, meaning that section 2 is the only correct option. Now look at section 1. It said P1 cos theta 1 is equals to P2 cos theta 2. That means if P1 cos theta 2. That means if you have a particular force, let me say 5 Newton force, that's my P1. Then cos theta 1, the theta is theta 1. Okay, let me say 30. Then cos theta 2, let me say 50. That means the thetas are not the same. If the force are the same and the angles are not the same, it will never be the same. That means option 1 can never be the same because the angles are not the same. Then option 3 can be correct because the forces are not correct. They can't amount, like if I have 5 Newton force as my P1 and I have 6 Newton force as my P2, they cannot be the same because the 5 and 6 can't be the same. Even if you multiply with the cos, it won't give you the same value. So the two of them are wrong. The only correct thing is that if you add up the two forces acting on this side and you make it equal to the force on that P3, it will give you the same value because they are in equilibrium. Okay, and that makes option 2 the correct answer. This brings us to the end of this video. Don't forget to like this video if you really want to get more content from us from time to time. Until we see, take care of yourself. Bye for now.